your AI model made a mistake. You measured it using the loss function. But now comes the real question. How does it actually fix itself? Hi, I am Tiyasha, an AI engineer, and in this video you will understand how neural networks learn step by step using something called gradient descent. Imagine you are standing on a mountain blindfolded. You want to reach the lowest point. What do? You take a small step in the direction that goes downward. That's gradient descent. The gradient tells you which direction increases the loss the fastest. So if you want to reduce loss, you go in the opposite direction. Now let's zoom inside a neural network. Each node receives inputs, applies weights, produces output. Now here's the key idea. Every node contributes a little bit to the final error. So we ask, how much did this node affect the loss? That is gradient at the node. Let's take a simple example. Output is equal to W into X. Now we want, how does changing W affect the output? The answer is the derivative, which is X. So if X is large, the impact is big. If it is small, the impact is small. But neural networks are not one step. They are many layers stacked together. So how do you compute gradients? We use the chain rule. This means final loss depends on intermediate output depends on weight, so we multiply gradients step by step. This is what powers the backpropagation. In real life, you don't compute this manually. Frameworks like PyTorch, TensorFlow do it automatically for you. While working with these frameworks, gradients are calculated automatically, which is called the automatic differentiation. In TensorFlow, you explicitly record the operations using gradient tape, but in PyTorch, the graph is built automatically as you go. So whether you use TensorFlow or PyTorch, the idea is the same, automatically computing gradients through the chain rule. You remember the formula of gradient descent? Remember the step size? That's the learning rate. If it is too big, that means learning is overshoot. If it is too small, then learning is very slow. Choosing this properly is crucial. There is different versions of gradient descent. Say batch gradient descent. It uses the full datasets and slow but stable. There is stochastic gradient descent or SGD. It says one example at a time. It is fast but noisy. Then there is mini batch gradient descent. It has the balance of speed and stability. Then there are advanced ones like ADAM, RMS-Proc. This adjusts learning automatically. So loss tells you how wrong you are. Gradient tells you how to fix it. Gradient descent updates parameters. Repeat this many times and your model improves. If this video helped you understand how AI actually learns, hit like, share and subscribe to my channel, and I will see you in the next video. Till then, goodbye and happy learning.